Hello, this is Ron Armstrong from the xLights Zoom room, and today I want to talk about using a countdown using an FPP plugin on a model that contains a matrix and is not just a unique matrix. So we had a user in the Zoom room the other night with one of these Boscoyo Tune 2 signs, and he wanted to have that out before his show and then scroll a countdown on the matrix part of this model to show the number of days, hours, and times before his show actually goes live. That methodology would use an FPP plugin manager, would use a plugin called the Simple Countdown plugin. And everything I describe in this video is just one method of how to configure so you can do the simple countdown method on a model that is not a true matrix model but contains a matrix model. There are multiple ways you might be able to solve this equation. This is one method. I'm going to leverage a shadow model with a specific offset to associate with the matrix part of these other models. So as is, if you use a simple countdown plugin, it has to output to an FPP pixel overlay model. So let's just talk a bit about the plugin. So simple countdown configuration. You come in here, you can enable the plugin, you give it your time to your event, your date time to your event, like December 6th, what pretext do you want, post text, and then what's the title. So you fill out that information and you'll get something like this. It is 28 days until launch, whatever launch is, until opening, 28 days until opening, 28 days till Christmas, whatever the date event is. And then you can include hours and minutes, or just include just the hours. This isn't a full overview of the plugin, just the plugin usage. So you would have your text, and then you would define the font size. So font size is going to be very important for these model types because your font can't be larger than the number of pixels high for your matrix. So you have to make sure and play with your font type and your font size for this to actually output. But the key is you have to select the matrix name that you want this to play against. And I don't actually have an actual matrix. I've got these models that's a complete model that's not just a matrix, right? So I have to tell this video we're going to focus on this chroma hat. The user in the room the other day had a Tune 2 sign. Then there's another user we saw on Facebook that's using one of these Boscoyo chroma hats with the matrix. I personally happen to have an ornamatrix in one of my shows, so I'm going to use this methodology. I have not used this in the real world yet, but we came up with it in the Zoom room with this user, and it worked beautifully for him. So I will now leverage this method to do the same kind of thing on so any model that is like a custom model that contains a matrix submodel. Normally you would sequence on the, so we're going to focus on that. Normally you would sequence on the submodel definition. So there's a submodel that contains just the matrix. So in your regular sequence, if you sequence text onto the matrix submodel, then that text would be displayed on that matrix submodel. However, that does not work for this simple countdown plugin in FPP because it has to scroll to the entire model, not a submodel. Then you have to pick the model that this would scroll to. The model list in FPP specifically is a pixel overlay model. And if you go to input output setup and pixel overlay models, you can see what models are contained. Now these models were uploaded from xLights via FPP Connect. We'll demonstrate that in a little bit. So if you knew precisely the starting channel number that represents the starting channel for your matrix and the precise channel count for that submodel matrix, you could potentially just add a pixel overlay model of a channel type, call this matrix only as an example, give it the correct starting channel number. I don't know what that is, but let's just say it's 356. We'll have to calculate that, right? But I have to manually define the starting channel number, and that's the absolute channel number as defined in xLights. Let's actually just figure that out, right? So if I go to the entire hat model, this is 1459 is the starting xLights channel number. And if I go to wiring view, make this really big so you can see it. And this is a good point to demonstrate that this method will only work if the matrix submodel is a contiguous string of pixels. You see how this serpentines or zigzags back and forth. It starts here on this model. It starts here at number 140. Remember, this is a back view, so technically this is the right side of the model. So this would be the lower right, the number of pixels to the right, and then up, and then over, up, over, like a typical matrix zigzag model. So as long as your model contains the matrix that is contiguous pixels, as in not jumping out to the outline and back and forth, then this method will work. So since this is pixel number 140, we need to figure out what that start channel would be in xLights. A couple of ways we can determine that, by either math or we can take a look at the submodel details. That will give you the node number. That actually won't tell you the channel number, so we will have to do math. This matrix on this hat, I counted these earlier. This is 21 wide by 8 high. This top row is considered part of the matrix outline, not the actual matrix. So look at the wiring view, see where it starts, what node it starts on, make sure it ends, and notice that this is the very last pixel for the model. So when we're all done, we'll showcase that the end channel in xLights should align with the end channel at the model because that is the last pixel. Close wiring view. And yeah, I don't think this will tell me on the submodel. It won't tell me what channel number. So remember, it started at channel PowerShell here. Oops, that's not what I wanted. I'm going to use PowerShell to do math. So what is the starting channel of pixel 140? So we take 139, the previous pixel, times 3. That's the end channel for the previous pixel. So that means the start channel for 140 would be 118. And remember, that's relative to the start channel in xLights, 1459 in this case. So let's figure plus 1459. And that gives us 1877. So in my pixel overlay model, that's the start channel I'd have to calculate. 1877, is that what it was, right? 1877. And the number of channels. So how many pixels is it? It was 8 by 21 pixels, 168 pixels in that matrix. And we'll do 168 times 3 to get the number of channels, 504 channels. So that'd be 504 channels. Horizontal, I'm going to call this start corner top left. I'm not sure the best option here, and I don't have one of these models right here to actually test the output. We can demonstrate in xLights if it works, but I don't have the actual output. So you may have to choose a different start corner if your text is backwards or flipped or something, but I'm going to leave it on the top left. because that's basically the start corner is going to be this start channel, which technically is the bottom right. But regardless, so let's save that pixel overlay model, restart FPPD, go back to input output, set up simple countdown. Now I have an overlay model called matrix only that would be represented by that manually created pixel overlay model. The significant challenge with this method is if anything changes in xLights and I reassign this model, move it to another controller, if I have this assigned on a controller and put a different model on the controller, this xLight start channel number is going to change. If this changes, then you have to recalculate that start, and you have to remember to go back here to your manual pixel overlay model and recalculate the start channel, right? So that can be a challenge if you make any changes or edits to your show, and then you're like, why is this not working correctly? So the method I'm going to use with the shadow model would create a model in xLights that overlays on that matrix section of the real model that allows it to have an associated channel number. So even if things change in xLights, your model overlay that we create, your pixel overlay model that we create and upload to FPP will always be adjusted according to xLights. So if you make a change somewhere, then it'll, and we can demonstrate that by just changing the start channel in xLights. So that's one method to accomplish this goal, but probably not the preferred, because they're like, hey, you got to figure out math and you have to figure out position and blah, blah, blah. So I'm going to delete this. Save, restart FPPD. So now my plugin is currently not associated, or it automatically switched to the first available model in my model list. But when you output to this model, you're effectively not outputting to the matrix. So part of your text will be displayed on the hat, on the spinner, part of your text, and you just won't be readable text. All right. So I know I was going to try to keep this concise, but it's a little bit more technical detail. So to create your shadow model, let's go ahead and move into that step. In xLights, I'm going to just take a regular matrix model, drag and create the matrix model. Now this setup part is going to be dependent upon which model you're trying to shadow with this. So we'll just call this guy hat matrix, for lack of a better word. So we'll name him because he's going to be basically overlaid on top of this matrix section here. And here's going to be one string or one controller connection, because when we looked at this wiring view on the model, this is basically one continuous string, right? And even if physically you're interrupting this with different connections on the master model, this shadow model that we're creating will be one string continuous for the duration of this zigzag standard matrix definition that we're creating. Matrix. So it's going to be one string. Where we figure out 8 by 21 is 168. So that's going to be 168 nodes. And the strands per string will be the number of zigzags, which is your vertical dimension. The wiring is horizontal because that's the way it is in the model. And it goes 8 high. That's the number of zigzags. So this model now matches. And just for grins, I always, when I create a matrix model, I always right click and correct aspect ratio. That makes sure this guy is evenly spaced so that your text will look proper as you might expect when it outputs. All right, so on this matrix hat, remember when we saw the wiring view, that first model wiring view, enlarge that. When I'm scrolling over here, that is 140 is going to be the first part of the matrix. And this is a reverse view, so technically this is bottom right. So I'm going to make sure and close this and set this matrix starting location to be bottom right. You also notice my little, the cyan colored pixel shows you your starting location on a lot of models. Like here on the order matrix, this is pixel number 1 on that order matrix. On your hat, pixel number 1 looks like this bottom corner there. That bottom corner is your starting pixel. So cyan color shows your starting pixel. Bottom right. All right, so here's the magic sauce, is we need to assign the channel numbers just like you would a shadow model. If you're not familiar with shadow models, plenty of YouTube videos on shadow modeling. But we're never going to use this model on the controller. We're going to come into the settings here and we're going to specify to use a specific start channel. Then this start channel field, we're going to edit the start channel field. We want to make this guy relative to the hat. So we're going to say this is going to start at the beginning of the matrix hat model. And you know, he was pixel 140. So the pixel 140 count, remember we did the 139 times 3, that's the end of 139. So the beginning of 140 would be 418. So up here in the start channel, we're going to specify 418. That's going to be what channel relative to the start of the chroma hat are we going to start our matrix on. You'll notice that your channel assignment information, commonly you would have the chroma hat, you would have this will be relative to that. So sometimes you'll have like an exclamation point controller name. When you use your visualizer to assign models, you'll have the controller name and then the channel information. So here you'll have an @ sign. An @ sign means it's related to this model, and it's starting at 418, which will be 1876. Ends at 2379, but I would expect that to end. Oh, I'm going to retract something I stated earlier. Wiring view, enlarge. This top row is not actually part of the matrix. So the matrix technically ends at 307, not 324. And I'm able to notice that if I zoom in on the hat, select the hat so it's highlighted, double click the hat to expand the submodel, select the matrix submodel. So the matrix submodel that you would normally sequence on, you'll notice is not contain this top row. So the matrix is inside of this. Will be model specific. You'll have to figure out on your model where the matrix typically starts and ends. When I select on this matrix model, you can see it starts here. So this matrix model is inside. So that last row does not, which means our end channel will not align with this model. But anyway, this guy should be right. And I was one off from my channel numbers of my math. Should be 1876 absolute xLights channel number. So when I created that pixel overlay model manually, you'll notice even if I did the math, I was off by 1 channel. So my coloring would have been wrong. Anywho, so now I've got this hat matrix. The hat matrix shadow model that is created for the actual hat. The hat model you would drop onto your controller for controller port assignment. You will never put this guy on the controller port. This video is also not specific to shadow models. I'm not going to go into depth, but effectively you would go to your main model the model that you assign to the controller. In this case, it's going to be the hat. We're going to go to the shadow model 4, and we're going to say this is a shadow model for the hat matrix. This only gives you, that technically doesn't make a difference in the sequencing, but what the shadow model 4 hat matrix. I'm going to show you now in the visualizer what that does for you. It gives you a visual clue to not do anything with this model on the visualizer. Notice the hat starts at 1876, which is an offset from the hat matrix, which is on 1459. Let's go ahead and add, I don't have a controller set up in this test folder, so I'm going to go ahead and just add an Ethernet controller real quick. We'll call this, controller. It's going to be FPP, and say it's an FPP Pi hat. Whatever the controller is, doesn't matter. It can be a Falcon or anything. Let's actually just do that. Let's say that this is on an F16 V4. Sure, why not, right? And maybe I want to run a default port brightness of 30, and I say my IP address is 192.168.4.20, whatever the IP address is, who knows. I don't have an actual model attached to a controller, so I won't be outputting to the controller. So in this scenario, this would be the correct controller definition for whatever controller. So let's visualize. And you'll notice here on your model list of available models, you'll notice that this hat matrix is gray. So this means if you see something gray here that's configured shadow modeling, the gray you never want to touch. You never want to drag it over onto your controller and drag it back, because that will change that start channel that we manually configured. Also notice when you mouse over, the borders are dotted. Borders on dotted means these are related to each other. And the non-shadowed models, it's a solid border. So that's what that shadow model 4 setting gives you. It just gives you a visual indicator to say, wait a minute, that guy's grayed out. I need to leave him alone. So the hat matrix that we created is the one that we do not want to assign the hat. So let's say we'll just put this guy on port 3. Then maybe this guy's on my port 3 of this Falcon. You will get, when using shadow models, you get a warning down here that just says, hey, by the way, a hat matrix is shadowed by the chroma hat matrix Santa. So yes, we did that purposely. So this is just a warning to let you know that. Sometimes we've seen that shadow model 4 setting get set erroneously. So pay attention to these warnings. Warnings are fine, errors are bad. Warnings, as long as this is purposeful, which it is, then it's okay to ignore the warnings. So let's close that, hit save. If I go back to my layout, you'll notice that my channel numbers for the chroma hat matrix are now different. So because it's the first assigned model, its channel number is channel 1. In parentheses is the xLights absolute channel number. And then my hat matrix is now absolute channel 418. You can see how it followed that relative position. Right? And if I go back to my controller and say, well, I got this Warner matrix on channel 1, right? Close that, save, go back to layout. You'll know these channel numbers now changed once again. So now my hat is actually 1501. And my matrix is now 1918. So you can see how that moves. So if you make any change on the visualizer, your channel numbers shift. So now we have an actual model that shadows and overlays the actual prop, the matrix section of the prop. And it channel numbers, when things change, as channel numbers follow. So you no longer have to calculate and figure out what the channel numbers are going to be. All right, cool. Moving on. Let's take a look to see if this actually works before we go to the next steps. All right, so let's go to sequence, and I'm just going to create a dummy animation sequence, right? Boom, got my models. I'm going to drop an on effect on that matrix Santa hat. And I want to make that on effect red. And if I show my house preview, you'll notice that both of those are lighting up because remember the channels are purposely overlapping. They're purposely overlapping. But let's make sure our starting positions are in the right place and all that, right? So I'm now going to go to my hat matrix model, and I'm going to go to strand 1, node 1, and just to identify the node 1 of the matrix model, and let's set that to white. Okay, not sure why that didn't change. Oh, I know why it didn't change. Because of my render order. Right, the hat matrix is above this, so remember render order from the master view is top down, so my red is overriding everything. So I'm just going to edit display elements, bring my hat matrix below the center matrix so I get the proper render order, and then let's go back and reselect that guy, and you'll notice I have a white dot show up. So house preview. So I'm turning on just node 1, which was not the proper duration. So let me just extend these out to full so it doesn't blank out on me, right? So pixel 1, remember the hat, technically it's the bottom right. The wiring view, it was on the left because that's the reverse side. So, but it's technically, this is where position 140 is. So the first of my shadow model lines up exactly with the first of the actual model. So this is just a little test to make sure things are lining up. Remember, we went 21. So if I go 21, that should be this far left side, right? So if I go back to node 21, and let me just say let's drop a white on node 21, and take a look at house preview, you'll see I now have the first and last of that first string, and that aligns exactly. Right? If I go to the last strand, that was on strand 1, let's go to strand 8. Dropping on effect on node 1. I'm just highlighting the corners here real quick just to make sure that, you know, what we did kind of aligns, right? And then let me just copy that and drop that on node 21 as well. And then house preview. So all 4 corners of the matrix should align. 1 corner, 2 corner, 3 corner, 4 corner. So this is just spot checking the overlay work that we did, the shadowing when we did our start channel offset. So yep, I think that is all really good. Now let me model, delete node effects. I don't know if that's really going to delete everything or not, but it's there. Now I have no more anything on there. So just take the text effect, drop the text effect on the hat matrix. Now you can either put text on the hat matrix, or if you prefer, you can still use the matrix submodel. So let's just drop text on the hat matrix if you want on this new model. Just say this is fun. And let's remember that the matrix is only 8 high. And so you're cutting the S's off. So your font is going to matter. You're likely with the smaller matrices using an XL font. Maybe we'll come down here to 8x8 thin. And, you know, and just play with some of these smaller fonts. A 10 will be too tall. You won't get everything. Maybe 8x8. Oh, we don't want vertical, but maybe a 7x9. And just play with some of these OS fonts. Maybe a 6x6. And find a text that you like. I'm going to put movement to left. And you can kind of see how this scrolls across, right? So you'll just have to find a font that you like based upon your matrix size. The 8x8 text. So now that this is playing, let's take a look at the whole house preview. And you can see I'm now getting the text on both the hat as well as, let's actually light, let's drop like, I don't know, maybe we'll make the hat white and the text, no, actually I wanted the hat red, yes. Text white. Why not, right? In case you wanted to do something kind of layered, I don't know. I mean, maybe that doesn't look as good as you want, but oh, I've got red and white turned on the text, which obviously it's not seeing. And house preview. So I just wanted to put something on the hat so you can see how this is actually displaying across the hat. And all my things don't actually align here. That's why it's kind of blanking out. So you can see I can text on the shadow model, which will show up on the hat, or I can text on the hat. Let me do a cut and go to the matrix submodel, and we'll paste, align that a little bit. And because of the way we created the shadow model, they're exactly overlapping. Whether I add text on one or the other, they both will work. Fun? Cool. So now we know that our overlay model, our shadow model, is overlaying the matrix submodel, and this is working as expected. Sweet. Now we need to get this. I'm gonna cut this off of here, put it on the hat matrix model. Again, I'm just going to move these to the left. That way they're kind of somewhat aligned. Now I need to get this hat matrix model into FPP. Right, so when you do a FPP connect, sequence is not yet saved. I don't care about this sequence, so just a demo. FPP connect, and ignore all of these other FPP instances. I have a few. Right now I'm just working with this guy called testpy3, and the model column, if you set that to all, then when you do an FPP Connect upload, it will upload all of your model data from xLights to your FPP instance. And then we'll be able to use those models for the simple countdown plugin. So I'm going to just hit upload. And it just sent that configuration to FPP. So now we come back to FPP, input output setup, pixel overlay models. Now I have this hat matrix overlay model that's automatically configured for me here. And so this probably the settings we would have wanted when we manually created it. But notice the start channel is 1918. That should always match what's in xLights. Right here, this one, 1918. And if I configure my simple countdown, come down here, select the hat matrix model that we created. Now this simple countdown text, when we run this simple countdown text, it will display on the hat matrix model, which technically is overlaying on top of the hat. And as we demonstrated here, any text on the hat matrix model should be displayed on the hat as well. To run the simple countdown plugin, you have to use an FPP command. When you installed the plugin, it created a simple countdown plugin, simple countdown run. And when you do a run, that will play that text. That text will scroll across one time and done. So it's a one and done because it's a simple countdown. So if you wanted that to play over and over again, I would create like a playlist, countdown playlist, and add playlist. We're going to add a playlist entry. The type is going to be an FPP command, and the command is going to be simple countdown run. There it is. And just add that entry into a playlist. When using FPP commands in playlist, that's an instantaneous. So if I just use this playlist as is, it'll start based upon the loop, and that's not what you want. So if you're doing like commands and you want something to take time to complete, we're going to also add a type pause. And let's say we pause for 60 seconds. Add. Save playlist. So when this playlist runs on a loop, it'll scroll the text. Then it's going to wait 60 seconds. Scroll the text again. Wait 60 seconds. Now this pause you would configure for whatever time you want between the time that the text scrolls across. Okay. So now we would just want to like schedule, and it's out of schedule, and say I want to begin today at like 5 o'clock. Or maybe I start at, maybe I start running at 5 o'clock p.m. I don't know, 5 o'clock, probably not a.m. but p.m. And I'm going to call my countdown playlist, and I'm going to let that play. For now, I'm going to say let that play till 10 p.m. And maybe I only want that to happen up to the event day. December 6th is what I think I set to, right? So now if I preview, it's going to play that countdown all those times up to December 7th. Did I pick December 7th? Oh, 2029. If you're trying to get the schedule to stop at a particular time, make sure and pick the correct year, December 6th. Save. Preview. And this preview only shows you 14 days anyway. So if it's too far, so it'll start. But technically, I probably want that to be different on the 6th. So I'll probably set a different schedule on the 6th to end before showtime, right? I don't need xLights right now. So now we scheduled a countdown playlist that contains the command to simple countdown run, pause, play it again, pause, play it again for the duration of my cycle. And that simple countdown run will take the simple countdown text, whatever I've populated and created here, and it will take that and play it on the hat matrix model, which the hat matrix model is the overshadow overlay model that we built that purposely overlays the matrix on the hat. One other thing I'll demonstrate. So remember we demonstrated a little bit about how if I make a change on visualizer, the channel numbers change. Right. So now everything in FPP is configured and it's playing, and maybe I'm getting ready for my show, and I say, well, really, I want to add something else. Maybe I got some other model I want to put on port 2. Close, save, go to the layout. Now my hat matrix that I need to output on is now channel 3376 because I made some change in xLights, so 3376. And my model that I'm displaying text on is not that channel number, right? So maybe I made some other change. Okay, that's fine. Made other changes. Maybe I do an FPP connect. Don't worry about the sequence. FPP connect. Wait for this discover. I'm just going to upload. We already talked about the model setting set to all. Come back to FPP, browser refresh. Now that channel number automatically updated. There's nothing to ever change. So if I make changes in xLights, remember to FPP connect and upload, then this schedule will continue to work as expected, playing the countdown on your matrix submodel that happened to be shadowed by an overlay. I know that's a little bit technical detail. It got a little bit longer than I wanted to, but hopefully this video is helpful. And if you have any questions or have quick questions on your show as we're all getting ready for show season, feel free to stop by the xLights Zoom room. And many great helpers in there will be more than happy to answer some of your questions and do their best to get your show running. So have a great season and enjoy the holidays.